Hi, I am Heather Schultz from Stoutfield Elementary, grade 5. Today we are with Mr. Crosslin, studying the states of matter. We are investigating which is the best way to slow the rate at which ice melts.
Ice baby. Ice baby. No, not ice baby. But we're going to learn how states of matter change from solids, liquids, and gases. You know, what state are we in?
Indiana.
Right. But these are different types of states. Another name for it is phases. So you're going to do an investigation. And it has to do with, we're going to take some ice, right? And we're going to put it in 3 bags. And these bags are very interesting. In fact, one bag is going to be wrapped in wool. Now, wool comes from a sheep, usually. And another bag we're going to wrap in newspapers. A newspaper is from trees and wood and turned into paper. The third bag we're going to leave unwrapped. So I want you to think, and I'm going to ask you a question in just a second. If you're outside cold and you wanted to stay warm, what should you wrap yourself in? Wool, newspaper, or plastic bag? Let me ask you and see what your responses are. You think wool would be a good insulator, right? Why?
Because wool is warm, and when you're outside and you're cold, you need something to stay warm.
Okay.
It's like a wool blanket.
So that would keep the cold ice in, right? Well, maybe you're right. Anybody else? Anybody think newspaper? Why do you think newspaper would not be a good insulator?
Because then you'll be really cold. Because the newspaper is just paper that you can easily rip.
You can easily rip it. I like how you're thinking. Okay, that leaves the plastic bag. One more student who thinks a plastic bag could possibly work, and why?
Because whenever you're breathing out heat, which if you're wrapped in a plastic bag, the body heat's going to stay and you're going to keep yourself warm.
Oh, I like your thinking. Okay, so let's take a look at our science workbooks on page 162, and there's a few things. Now, on this investigation, we have a question. Would you read this question out loud? Really loud for me?
Which
Insulator
is best at slowing the rate at which ice melts?
Which insulator is best at slowing the rate? So not only are we going to do ice melting, we're going to do the rate, how fast or how slow it is, right? So if it melts fast, that's not a good insulator, right? You go outside and you get cold really quick, you're not insulated. Now we're going to state a hypothesis. You guys repeat after me. Write a hypothesis by circling one choice. Okay, let's finish this question. Now you can decide. Do you want a bag containing ice cubes that are wrapped in wool cloth, wrapped in newspaper, or unwrapped? So go ahead and pick A, B, or C. Which one circle do you think would be the best at slowing down ice melting? What did you write? Okay, so say it. Go ahead.
If it is unwrapped, there's no heat to make it melt.
I like what you're thinking. I am not saying it's true, but I like it. What did you write?
I think it was because if you stick it in cold water, then it will not melt, but if you stick it in heat, then it will melt.
Okay, I like how you're thinking. Okay, so the next section says, in this experiment, you will measure the time it takes for each ice cube to melt. You will change only one variable. Everything else must stay the same. What should stay the same? What are 2 things that should stay the same? Okay, so a couple of things we're going to do the same. We're going to use water. It would be good to put some with milk and some with water. We're going to use all water. We're going to do it on the same day. We're going to do it the same way. We're not going to put some in the sun and some in the shadow. We really want what's called this, a fair test. Now, what's the one thing we're going to change? What are we going to change?
The outsides.
The outside of the what?
What's left around?
We're going to change the insulator of the bag, right? And so one, we're going to have wool. What's the other one?
Newspaper, and then
The third one is just going to be unwrapped. And you know what we call that in science when we leave one alone and don't do anything to it? It's called the control. The control. So that one is the control. Go ahead and add that to your notes. Okay, so, to help you understand this a little bit better, on number 4, let's draw a picture. You already have a box that looks like this. Yes, yes? Say yes, yes. Yes, yes? Okay, this is number 4. And so I'm going to do this super quick. Let's see if you can do it faster than me. So I'm going to do, here's one bag. Right, yeah. Here's another bag, yeah. So far I haven't misspelled the word yet. Here's another bag. This is A, B, and C. Yes, yes? What's A wrapped in? Wool. What's B wrapped in? News paper. And what's C wrapped in? It's unwrapped, right? Okay, I drew that. So this one we'd actually see the ice cube, right? Draw an ice cube in there. This one, we'd see a nice picture. We'd see some writing. Why would we see these? That's newspaper. And this one, it's going to be nice and hairy because this one's covered in wool. Go ahead and make your drawing look something like this. Okay, so step 5 is actually something kind of fancy. We call it the procedure. And the procedure is like, how are you going to do this? What are you going to do? What are the steps? And this is almost like baking a cake. So when you write this, anybody in the room or the school should be able to go through the list and do this. So here's number 1. Here's number A. A, prepare 3 bags with 4 ice cubes. Got it? Thank you. B, ready? Measure the mass. I'm going to put a G there. You know what that stands for? Measure the mass grams of that stands for each bag. And record. Got it? C. Wait 10 minutes. Pour out liquid H2O. You know what that means? D. Repeat. B. E. Repeat. C. Guess what you do for F? Repeat. Oh. B. And finally, G, we're going to repeat C. How many times are you going to measure the mass? 4. We're going to do it here, measure the mass, here, and here. At least 3. All right? I'll give you a few seconds to get this copied. Okay, so just to recap, the procedure is we're going to prepare the 3 bags with 4 ice cubes each. We're going to measure the mass of each bag and record it. We're going to wait 10 minutes, pour out the water, that's the melted. Then we're going to repeat B, which is measure the mass. We're going to wait 10 minutes, measure the mass, wait 10 minutes. And you know what? Let's do one more. Let's repeat B one more time. Is that okay? Okay, excellent.
Where are we going to set the record at, Mr. Crosslin?
I thought you'd never ask. Hey, let's turn the page and let me show you where we're going to record this. Here's what the chart is. In your book, it kind of looks like this already. So we got to add a few more lines to it. So it has this one big line at the top. Yes, yes? It has a divider right here. Yes, yes? And then it has 4 lines going across like this. Yes, yes? So this really helps me understand what we're going to do. Here's what we're going to do. Take your pencil and let's divide this one more time. And let's divide this one more time. Now we have some spaces. Let's do this right here, write the word start. That's the starter investigation. How long are we going to wait before we find the mass each time? 10 minutes. So here's 10 minutes. What's 10 more minutes going to be? 20 minutes. What's 10 more minutes going to be?
30.
You guys are way ahead of me. All right. And so this, we're going to call this A, bag A, this bag B, and this C. What is A? He said, and they answered wool. What's B? He said, and they answered Newspaper. And what is C? Unwrapped. See where we're going with this record sheet to answer your question, young lady? Oh, what are we going to measure in? Bananas, inches, miles? So go ahead and put a G by each one of these. And this ought to tell you how many times are we going to have to find the mass? How many times altogether in this investigation? 4 times for that. 4 times for that. And what's the total amount then? 4, 8, 12. We're going to find 12 measures. Go ahead and make your graph, your record, look like this. Okay, so we're going to use a kind of sophisticated balance scale that finds the mass of something. This is different from weight. Weight is a relationship of force of gravity. So weight, like the weight of this book, the force of gravity would be different on different planets. On a big planet like Jupiter, this would have more force, and we use a spring scale, but on the moon, less weight. But a balance scale is true wherever you go because we put something on this side and we move some masses on this side. That's why I always go like that for a balance scale. Now I love this. These things are zeroed out, and they're kind of, so a couple things. Always make sure to test them that they're zeroed out, and if not, and they should be level. And that one's, I can adjust this just a little bit with a knob here. Bam. Perfect. Now let's see if you guys know this. So you put the item to be measured here. Yes, yes?
Yes.
Okay. Oh, I've ruined it. What happened? No, I didn't ruin it. It went up, right? So now I should start with the hundreds. Now, it's important that you go from notch to notch, not in between. 0. 100. Not enough. That book's more than 100 grams. 200. What kind of book is this? Oh, so 300 is more. So what do I do now?
Go back.
Go back where?
1.
Go back 1 to the 200. So we know it's like, and make sure you see how it clicks in. Okay, clicks in. So this is 200. Oh, that's not enough. What?
Move the top. Move the top.
Tens. 200. 210. 220. Not a 200 and. Oh, 230. So that book weighs 230, right?
Move it back 1 and move the bottom 1.
Oh, so you're saying move the 10s back to 220 and then use the 1s down here, right?
Yep.
Okay, but you know what those little things in between are? You do? Points or tenths. You guys are smart. Okay, so there's 221, 222. And sometimes I just use my, oh, so 222 is too much. Let me back it up. Ding, 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 ding. Oh, tell me when to stop. So it is between the 1 and the 2, and if you count those ticks, I count 1, 2, 3, 4, I count 6. So it's 221.6 or 221.6 what? Bananas?
No.
Grams. So you do know how to do this. Okay, we'll see then, because you have to do this 12 times. Are you ready to get started? What does it say we should do, Lily?
Prepare 3 bags, 4 ice cubes.
Did you hear what she said? Prepare 3 bags, 4 ice cubes each. Go ahead, get started.
Okay, why don't we put some salt in there?
Feels like ice.
1, 2, 3, 4. And how many do you have in there?
4.
Excellent. Everybody, have you prepared your 3 bags? Yes. So here's the deal. I was in a room last year, and when I went in there, I saw a kid do this. They were holding one bag in their hand. And I said, oh no, why do you think it's not a good idea to hold one bag in your hand? What do you think? Yes.
Your temperature in your body will go up into the bag.
Yeah. You heard she said the heat in your body. So would that be a fair test if we hold one in our hand?
No.
So the best way to hold them from now on is at the top. Okay? Yes, yes?
Yes.
Oh, then I went into a room and guess what the kid was doing? He had opened one up and was going, and I said, what are you doing? Why is that a bad test? Yes.
Because
Because the heat of you blowing out makes the ice melt.
The heat of blowing out made the ice melt. So I said, guess what? You blew 2 breaths in this one. Guess what he had to do? 2 in each one. But let's not do that. So let's keep it a fair test. Don't hold it in your hand. Don't blow into it. Oh, by the way, would you read number B for me? What does it say on your procedure? Hey, get started. Measure the mass of each bag. Let's see how good you guys are. And record it.
No, 60 wouldn't be enough. It has to be at 70.
And that makes it go all the way down.
Yeah, but you have to use this one.
We just started. It's our first bag. You just got here just in time. Good job.
Anybody done yet?
So come right here so you can see them. We're doing the first bag.
What's your measure? Nope, look, you guys, there's a problem here. Come check it. I'm not going to tell you what is the problem.
It has to be on the notch.
It has to be on the notch, so you can't put it in between. Put it to 100.
I have to quickly grade it. Write it down. Let's go.
Now,
What is that?
start over.
Back up. I'm not touching it. Okay, we have to add less weight.
Okay, let's move the arms. And it's perfect.
Okay, so let me count. 68. 68.8.
68.8. Excellent. Record that. That was the wool bag, right?
Why did I like it? Why do you not have anything
68
written
point. Let me see that. Good job.
down? Have you guys measured one yet?
68.8.
You're doing the wool right now?
Okay, so one thing we started this at 10:40. That was our start time. 10:40 a.m. And I have my first group ready. What was the mass of your wool?
67.5
67.5 what?
kilograms.
Kilograms? Those are the biggest ice cubes in the world. What do you mean? Grams. All right, go ahead. And now the newspaper. What was the newspaper? Come tell me.
36.5.
30 what?
36.5
what?
grams.
Grams. Very good. And last but not least, the unwrapped was
30.7
what? Bananas?
grams.
30.7 grams. Thank you. Hey, boys and girls, check this out. Oh, I got a problem here. Why are these different? This class was really good. 67.5 grams. 30. I thought we put 4 ice cubes. Why are they not the same mass? What?
Because each of them have like different outsides on them.
Oh, the different outsides. So that doesn't matter as long as we know that this one is 67 because of the wool. All right. It's about time for us to do something else. It's been 10 minutes. Read the directions. It says pour out the water and measure the mass again. Go ahead.
Water each of them, and then
I learned this
remeasure
from
them.
my dad. If you
Reweigh
put a
them.
little hole in it, it drains out the water.
I can't do number C because for one I didn't get the measurement.
Okay, so C was 36.5. Joy, did you get that?
Let's see how much water that. Let's see how much of a change is going to
Hey, 36.5 for bag C, okay?
If the ice cube comes out, reach in there and get it and put it back in. Seal the bag.
Okay.
Do that to the others. Put it in a different cup.
Well, and then you got your spoon.
Hey, you want me to hold this over?
Great idea.
I just separate them.
Do not say you can hold still so ice cube.
Hey, when you pour the water out, keep the cups separated so you know which cup is which.
Just keep them on the desk because everyone charges them.
Yeah,
Guys, you're
I
not
just
measuring the cups
put
of
it
water.
upside
You're
Wow,
measuring
not
the
much
bag.
coming out of the wool, huh?
The ice
Okay.
is about to come.
That's good. Next is the newspaper. Somebody can help him.
Yeah, I'm okay. I'm okay.
Someone should hold it.
Oh, thank you.
Here comes the newspaper.
No, mine's there.
Nice. Okay, so here's all 3 cups. The newspaper, the wool, and the ice. Wonder what's going to happen. Go ahead and find the mass of your new bags. Okay, so it's been 10 minutes. My group, what is your new mass of the wool bag?
60.3.
Oh, it went down 60.3. Okay, because you poured some out. Go ahead. Newspaper?
31.5
31.5 what? Bananas?
grams.
Thank you. And
24.5.
24.5. I can't wait to see how your measurements are going. Go ahead. Okay, so we're ready for the third one. Go ahead and pour out the liquid water and record your new mass measurements. Okay, we're ready for some more data. After 20 minutes, what's the wool?
59.2 grams.
59.2 grams. Excellent. What about the newspaper?
30 grams.
30 grams. 30.0. And
20.7.
20.7 grams. Hey, I need to show you something. Can I have everybody's attention for a second? Now, we can start looking at some of our data. We still have one more. Go ahead and wait 10 minutes. We have one more to do, but let's look between this one right here. This was 67.5, then it went to 60.3 grams. So if I did that subtraction problem down here, 67.5 minus 60.3, that's going to be 7.2 grams. And so right here, it lost 7.2 grams. Does that help you understand this? Let's look at this one. 36.5 minus 31.5 equals 5 grams, right? This one lost 5 grams. Let's do the last one. 30.7 minus what? 24.5, is that correct? That gives a 2. 6.2. Oh my goodness, look. 6.2 grams. So right now, which one lost the most? Wool. And then unwrapped, and then newspaper. Very interesting. We can do these two. Let's do these two. 60.3, 59.2. I can do that one in my head. It's going to be 1.1 gram. Let's do these two. 31.5, take away 30, 1.5 grams. Let's do these two. This one's going to be a little bit harder. It's going to be 3.8, isn't it?
Yeah.
I'll let you do the math on yours. So, all of a sudden now this guy is catching up. All right, go ahead and do those differences. Make your subtractions. You can start to see. Okay, so now let's take our last reading. My group, what do we have for wool? Your last reading for wool? What's the wool?
50.7
50.7 what?
grams.
Grams. Kilogram man. Newspaper.
25.8 grams.
25.8 grams. And unwrapped?
18.4.
18.4. Wow. I hope yours has turned out like this. I'm going to go ahead and do these real quick. So this one is going to be about 59.2 minus 50.7. That makes that 8. That makes that a 12. That makes that a 5. And that makes that, wow, 8.5. That one went down 8.5 grams. This one went down 4.2 grams. And this one went down 2.3 grams. Go ahead and make your calculations. Once you've collected all your data and you've looked at this, on number 10 in your workbook, I want you to set it up like this. For example, if you notice, this is your rate. On this side is mass, and let's go by fives. We start at 0 grams, 5, 10, 20, all the way up to 70 or 80. This column is going to be wool. This is going to be newspaper, unwrapped. And then down here are our different times. So you're going to end up with something that looks like this. At the start, this one was way up here. The wool was way up here at the start. See that? You understand what I'm doing on this bar graph? And at the start, the newspaper was something like this. Do you remember that? And at the start, this weighed less because of the wrapping. So that's how it was. And you're going to notice that after 10 minutes, what happened to all of them? This one went what? Down. This one went down. This one went down. And then after 10 more minutes, what happened? They went down more, right? Some of them not so much. So you're going to have to use real numbers on these. I'm just estimating them now. And then finally, the last one we just did is this right here. And now you can take the top number right here and subtract the bottom number, and you'll get your difference. The top number, the bottom number, and you'll get your difference, okay? Top number, bottom number, and you'll get your difference. And that is how you can analyze which rate insulates the best and slows down the melting. Got it? Good. Do it. Okay, I want to end this lesson with one thing that I hope you understand. We started with ice, a certain mass. Just because it melted, is it still water or did it change to something different? It's still what? Water. So that was a physical change. We didn't turn it into bubble gum. We didn't turn it into smoke. We just changed it from solid to a liquid, right? So the mass is still there. It didn't go away. To prove that, here's a bucket that has both water and ice in it. I'm going to put it right here. I'm going to find the mass of this. 500. Excuse me. Well, just a little bit. 500 and 600. Oh. 608. So the mass of this bucket, the water and the ice, is 608 what? Grams, right? Now let me ask you, if I come back in an hour, what's the mass going to be?
What? 608.
It should be, this was water, H2O, this was water and ice, right? Mm-hmm. If I come back in an hour, let's see what it's going to be. Meanwhile, 1 hour later, the ice is melted, and would you read what it is right now?
600.
600? And 8 what?
Grams.
Grams. Just because it changed from ice to water, the mass stays the same. If you don't believe me, try it yourself. What state are we in?
Indiana.
I thought we were in the state of confusion. No. One last time that we have to end this with, since this is an investigation about ice, what are we going to say?
Ice, ice, baby.
We dedicate this to your teacher, Mrs. Schultz. Ready? 1, 2, 3.
Ice,
ice baby.
My name is Amaya, and I was forced to videotape for Mr. Crosslin.
I didn't force you. I said I'd pay you. What did I pay you last time?
$600.
No, I did not. I paid you nothing. Thanks for your help. You were great.